Okay, good morning. My name's Sam, engineer from Engineer Associates, and as Steve and Gareth have said, I supported the university with the contract and the requirements for the biomass boiler installation. I have worked with the university for a number of years, and so I have a good understanding of the district heating system, the CHP, and I've worked on those over the last 5 years. So worked very closely with the university. I think that's been part of our success, that we've worked together pretty well. So today I'd like to talk to you a little bit about what the requirements are from the specification and how we delivered the project. Okay. In terms of contract, the form of contract we've used is the IMEC EIET MF1 contract. We use revision 3. This contract is established and is particularly good for delivering equipment supplies, and it matches equipment supply and installation, and it's got a very clear process for dealing with performance measurement through that process, through the project life cycle as you're going through the project. The principle was a turnkey approach, and the contractor was to design, select the equipment, install and set to work. That doesn't mean that the university and us have abdicated our responsibility with regard to selection of equipment. We were very clear about the functional specification, what we required from the equipment that we were going to purchase and what the performances we required were, and the process that was going to be used regarding design. And really the approach to carrying out the project. So the key elements are contractor design and equipment selection. There's three parties within the operation of the contract: the purchaser, the contractor, and the engineer. And the engineer administers the contract in MF1. And that was my role through the process, supporting the university to do that. In terms of process of paying, we used milestone valuations. So we identified equipment on site, equipment running. It's not based on an evaluation of equipment delivered through the process. It's actually based on key milestones. And that makes it that's quite a nice approach to apply for this. And we were particularly keen that we had, obviously, the guaranteed performances detailed, and we had extended warranties in place to make sure that what the university was buying was going to be delivered. Okay. So as part of the tender, there was two main elements which I produced, really, with a particular specification with the university. This looked at the technical and operational requirements for the boiler, for the fuel store, identified legislative requirements and installation standards that we wanted to apply, and also detailed the design and validation approach that we expected from our contractor supplier, and went through in some detail what was required from testing and for acceptance of the plant. I'll go into some little bit of detail about that on the next couple of slides. As part of the tender, I developed with the university a standardised tender return schedule, which identified total costs for individual areas, both CapEx and OpEx. So we're looking at the operational running costs as well. So we're looking at service costs over the life cycle, and these were taken into account in the tender evaluation. Performance guarantees I mentioned were part of this schedule. So there's an Excel sheet with the costs, with the performance guarantees in some detail in there. And then also looking at tender compliance. So we specified a 50-odd page bespoke tender, and we needed to understand that all of the contractors understood and were willing to comply with the details on every single one of those items. So the opportunity was given to contractors to comment on that, and then through the negotiation process, we could develop a project together. Okay. So some of the key points of the performance specification that we were looking at. We were looking to purchase a plant not just to tick a box for compliance and say we've got our biomass boiler in, it's required as Part L for planning or whatever. We've bought this to actually make a significant carbon impact and carbon saving for the university. So it's essential that we build a plant for a 20-year life, and that we had extended warranties in place with that plant, so we know that it's going to deliver what we need. We need reliability, flexibility, and as Steve and Gareth mentioned, we need to provide education opportunities as well for the students on site. So we've aimed to have an installation that gives those things. And you'll see as we go around, some of the access and visibility is aligned with that objective. We went into some detail around the boiler and the fuel handling requirements, which I'll go into. I've mentioned legislation and standards that we had to comply with. And also we required the contractor to support us with planning, to provide us with information and make sure that we met the requirements of the local authority who were responsible for overseeing the operation of the biomass boiler. So in terms of the emissions, the flue height, anything that's required along that nature, we required the contractor to support us with that. And then also in terms of design, how we were validating the quality of the equipment that was provided, and we carried out a hazard and operability study on the final design to look at failure modes and to ensure that the plant was safe and fit for purpose. Okay. Some of the stuff around the boiler, the particular requirements that we had from the boiler was that the plant was of a proven design with references. Now, we didn't specify we will buy a Compt boiler, a Wiesmann boiler. We said we wanted an established boiler with references that meets the RHI requirements. And we checked those references to make sure that what was being offered did that. And we had a range of boilers offered through the tender process. We wanted flexibility in terms of fuel as well, and Dave will talk a little bit about that. But we were looking from G30 to G100, so quite a range of particle size within the fuel, and also moisture contents from 30 to in excess of 50%. So we actually specified 12 fuel variants within the specification, and we required thermal efficiency guarantees at both rated capacity and at part turndown, and we got those guarantees from a range of suppliers, and I think that was quite useful for us, and I'll go on to talk a little bit about testing as well. Obviously, any boiler that we purchase would have to be certified for the renewable heat incentive, and there's some requirements there which I've just on the slide there that detail that. We also were looking at best available technology, so we need to comply with that, and there's some Environment Agency guys. I believe there's some colleagues from the Environment Agency here today, so they'll probably be able, if you've got any questions after us, we can perhaps discuss that. We also required that the contractor supported us in the design of the chimney, in meeting the requirements of the local authority, and that varies depending on the type of area that you're installing plant. In our case, we didn't require dispersion modelling, but that was something that the contractor would have helped us with if that was required. We're putting a system together made of a number of components. There's a fuel store and handling equipment, mechanical handling through that plant. We've got chain conveyors, we've got belt conveyors, and we've got a small auger feeding the fuel into the boiler. All of that needs to be certified under the machinery directive, and the whole system as a whole has been certified CE marked against that directive. We've also looked at, obviously, some of the key safety requirements from the plant were specified, whether it's fire protection against burn back within the biomass boiler. I mentioned machinery guarding, and gas monitoring within the fuel store and the boiler room. And also, lastly but not least, we need to meter the heat that we're getting out, and that needs to be compliant for the RHI, which is MID sort of class 2. So there's some of the key things that we specified around the boiler. On the fuel store, as Steve mentioned, we went through an iteration on this. Initially, we looked at a walking floor pit-type design, and the costs and construction challenges there were quite difficult. And I think if we had gone through that route, we would have probably encountered even more problems, Steve, when with some of the services that we did discover in that area. Being an old airfield, there was quite a lot of services that weren't picked up, and we had to deal with through the process. So the capacity of the fuel store we looked at, we were looking to get 2 loads in there. We struggled a bit on that. We've got a nominal capacity of 1.5 loads in there, but it depends on the loading and how that loading is carried out. We've probably got 1.2 in terms of capacity to easily load that fuel store. And you'll see a delivery hopefully this afternoon. I think Lucy and the team there and Mark are picking that up. Our transfers and handling of fuel we were looking at were mainly conveyor-based transfers. We avoided augers, long auger transfers, and those because some of the issues, especially with the large fuel specification range of fuel sizes, we were concerned about jamming and potential issues there. So we've as far as possible used chain conveyor and belt conveyors to handle the fuel, and you'll see that when you walk around. I've mentioned CE marking. Other interesting points on the building are making sure that we've got proper access control, not anyone can walk in there, that we've got low energy lighting installed in there on PIR. And finally, one of the things we had to take into account was we're operating right next to an airport, and during the delivery process, this can't be outside, and we can't have dust and objects flying around, and there's very strict requirements for that. So our delivery is actually is carried out inside the building. So the lorry reverses into the building with a walking floor and takes it out, and I know the LC Energy team will probably go into a bit more detail with their presentation. Okay, moving on. As part of MF1, the tests on completion we specified were required for taking over. It's not always the case, but we tweaked the contract slightly there. So as part of the taking over process, the tests on completion are completed. We looked at the output and emissions from the boiler with various fuels, and we used the BS845 test methodology using a direct method. So that method, we used the heat from the heat meter. We actually measured the heat we got out, and we measured the fuel that we put in. And doing that was quite tricky. That was a bit of a challenge because you're getting fuel delivered through an auger. So we were measuring the number of rotations on the auger as the fuel was delivered into the boiler, and then measuring the volume of that fuel. That fuel was then sent for lab analysis, and then from that basis we could identify the calorific value of the fuel that was put into the boiler over a certain period. We could measure the heat on the way out, and from that we can measure a direct measure of efficiency. Tests were quite long. They're 4-hour tests because we need a stabilization period, a running period, and then a period to just collate the results. Okay, as I mentioned earlier, we looked at, we did specify and had guarantees for 12 different fuel specifications. We actually tested 3 across the range, and you can see there the G30, W30, the G30, W50, the G50, W36. They were the actual fuels that we tested. And in all of those tests, we got around 89%, exceeded 89% efficiency on the net calorific value basis. That's part of the job, and in fact, we'd have been surprised in a way if we hadn't achieved that, because as part of the RHI certification, the boilers are tested for efficiency, and they're required to achieve that sort of level anyway. But we wanted to make sure the boiler we got on this day delivered the performance that we needed, and it was there for the next 20 years to do it. So it was important for us to test that, not just take it for granted that because it says it on the certificate that a generic boiler of that type would have that efficiency. Our boiler does have it, and we tested it to make sure that happened. Having efficiency is one thing, but we also need reliability. So as part of the contract, we specified a reliability requirement. So we had to run the boiler with fuel as delivered for 30 days and deliver an uptime in excess of 95%. We achieved that as well. So that was a great tick and a great performance by Clear Power and Flow Gas with the engineering and the integration of the plant they carried out. Just a quick sort of second and final point on RHI compliance. We had various boilers offered at tender, as I mentioned. The compliance is demonstrated by a type certification Ofgem certificate that looks at the efficiencies and the emissions. But it's very important that you look at that and check that any boiler you purchase, the exact model that you purchase is on that certificate, because Ofgem will look at that very carefully as part of the registration process, quite rightly too, because it's public money that's being dealt with, that's being distributed as part of the Renewable Heat Incentive Scheme. So check that carefully, that's quite a key. And as Steve mentioned, as we went through the process, we were very careful at different stage gates during the process that the boiler we had did have the correct certification. Okay, final point, a little bit on contract management. As I mentioned earlier, the 3 parties in the MF1 contract. The engineer administers the contract, issues the instructions, certification, so I do that sort of stuff. So if there's a technical instruction to be issued, we do that. Certificate the payments as well. The contractor has design responsibility, but the designs are submitted to both the purchaser and the engineer for comment. So through the process, working closely with Clear Power, they carried out the design. We supported them because we had a lot of detail about how the existing systems worked, and together we developed the design. The university looked after the planning side of things with their planning advisor and CDM, and coordination of all the permits and permits to work. Myself and Steve witnessed the plant in operation. We did that. We did the witnessing of the commissioning and the testing. And the plant was operational in January 15. So we got it operational for half of the heating season last year. And last year it delivered 1 million kilowatt hours of heat to site, just over 1 million kilowatt hours. Taking over was delivered in April 15. So we've been going for a year. And finally, I guess, has this actually delivered? Well, so far this year, we've had excellent availability and reliability, and we've had over 2 million kilowatt hours of heat delivered this year. So I think that's the end of my presentation, and hope you found that useful. And any questions, please capture me as we're walking around, have a chat when we're walking around.
Any points of clarification?